Okay, so what we have in this picture is the graph of a function, f of x. And what we're going to do to try to motivate concavity and how it comes about is to analyze the slopes of tangent lines. So as you notice at this point here on the left, we have a slope, and we're about at x equals about -3.5 or so. The slope of the tangent line there is a positive 43, so pretty steep. Okay, so what we're going to do is analyze what happens to the slopes as we move along the curve, as x increases. So looking at that, if I move along a little bit, you notice that the slopes are decreasing as we move along the curve here. So that's causing the curve to bend in a certain way, okay? And we keep moving to the right and we hit the horizontal tangent, and the slopes keep decreasing. Now we're into the negative slopes, and up until we hit this point P. Now keep your eye on the values. The slope there is -14.25, -14 and almost 3/4, and then we hit this point P, and then our slope is -15. Now as we move through P, going to the other side, notice the slopes are going another way, which is causing the curve to bend in a different way. If the slopes are increasing, it's causing the curve to bend upward, because as you move to the right, the curve is starting to go further and further up more steeply. So how does this relate to the shape of the curve? Well, let's look at this. So coming back to this part, when the slopes were decreasing, the curve was bending in a downward fashion. We call that concave down. Now let's think about how that relates to derivatives. So the slope, which is f prime, is decreasing. So remember that when a function is decreasing, its derivative is negative. So if f prime is decreasing, its derivative is negative. But the derivative of f prime is f double prime. Okay, so this is where the second derivative comes into play. When the second derivative is negative, that means the curve is concave down, because that comes from the slopes decreasing. Okay, if we go to the other side of point P here, this is where the slopes are increasing, causing the curve to bend upward, just like you see here, and that's where f prime is increasing, which means its derivative, f double prime, is positive. So that is where the link between the second derivative and concavity comes from, as you're going to read about in the tutorial.